Hello, everyone. It's now my great honor to introduce Dr. Mark Johnson, who was for many years the director of Jefferson County Public Health Department, which is where I first met him, meeting with him about Rocky Flats related matters. Upon retirement, recently he went on to more interesting things. Dr. Johnson was raised in Grand Junction, Colorado, attended Pacific Union College in Northern California and Loma Linda School of Medicine in Southern California, receiving specialty training in preventative medicine and his master's degree in public health at Johns Hopkins School of Public Health and Hygiene in Baltimore, Maryland. He's board certified by the American Board of Preventative Medicine and served as both the secretary and treasurer of that organization. He has served as the president of the American College of Preventative Medicine and both the Wyoming Public Health Association and the Colorado Public Health Association. Since retiring from Jefferson County, he's currently become the president of the Colorado Medical Society. He served as executive director of Jefferson County Public Health Department for over 30 years and was active in the advancement of public health. He was a leader in the campaign to pass legislation in 2008 to help revitalize public health in Colorado, and was a member of the founding steering committee for the Colorado School of Public Health. He served in the United States Public Health Service for 6 years and resigned his commission as a lieutenant colonel after 7 years in the Army Reserve. Mark is active in his church, where he serves as the chairman of the board and as a Bible class teacher, and he loves to spend time in Colorado outdoors. He and his wife have ridden bicycles over many of Colorado's mountain passes and have scuba dived in many of the world's most beautiful diving spots. They are the grandparents of 5. Ladies and gentlemen, please welcome Dr. Mark Johnson. Thank you.
Thank you very much. At about 5:30 on the morning of July 16, 1945, Jacobo Vigil was awakened by a thunderous boom on the Gualara Ranch southeast of San Pedro, New Mexico. Running outside to see what was going on, he saw an eerie red glow hanging over the Oscura Mountains. A bit later, after the sun had risen, Mr. Vigil went outside to begin his daily chores and suddenly realized that his barn was gone. He found it as a pile of collapsed lumber scattered to the west in a nearby bosque. It had been dark but clear at 5:29 a.m. that morning, with a light wind blowing after a rather violent thunderstorm had passed through the area in the Jornada de Muerto desert about 35 miles southeast of Socorro, New Mexico, when, in the words of historian Robert Leckie, a voice like the voice of the Creator spoke from above the black clouds. 0 minus 10 seconds. A green flare exploded in the darkness, illuminating the clouds before it vanished. 0 minus 3 seconds. In the east was the first pink blush of dawn, and then, out of the bowels of the earth, there shot into the sky the herald of another dawn, the light not of this world, but of many suns in one. The first detonation of a nuclear weapon, called the Gadget, occurred at the Trinity bomb site, exploding with the energy of approximately 25,000 tons of TNT. The surrounding mountains were illuminated brighter than daytime for 1 to 2 seconds, followed by thunderous echoes across the valley and beyond. A heat wave followed that felt like being inside an oven. The shock wave was felt over 100 miles away, and a mushroom cloud reached 7.5 miles into the sky. One observer described it this way: the lighting effects beggared description. The whole country was lighted by a searching light, with the intensity many times that of the midday sun. It was golden, purple, violet, gray, and blue. It lighted every peak, crevice, and ridge of the nearby mountain range with a clarity and beauty that cannot be described but must be seen to be imagined. The world had crossed the nuclear threshold. Some of the old-timers in the small towns around the Trinity site remembered having earthquakes in the area in the early 1900s and believed they were experiencing those again. Others felt they were experiencing a Pearl Harbor-like attack from the Japanese. But many of the locals looked at each other knowingly and said, "It's the bomb." Despite the high level of security and no evidence of anyone actually mentioning a new type of weapon being produced, many people in the surrounding towns knew the military was engaged in some secret project east of San Antonio, New Mexico. All of the unusual activity in the area had left the impression with folks living there that some sort of new weapon was being built, and these strange manifestations in nature convinced them of that truth. Almost immediately, though, the cover-up began. A press release from the Manhattan Project team leader later that day stated, "The commanding officer of the Alamogordo Army Air Base made the following statement today. Several inquiries have been received concerning a heavy explosion which occurred on the Alamogordo Air Base reservation this morning. A remotely located ammunition magazine containing a considerable amount of high explosives and pyrotechnics exploded. There was no loss of life or injury to anyone, and the property damage outside of the explosives magazine was negligible." The scientists working on the bomb in the Manhattan Engineer District, more commonly known as the Manhattan Project, had not known exactly what to expect, nor did they now know what the consequences of the explosion might be. Some of the unknowns would play out right there in New Mexico and the surrounding states. Far from being an uninhabited region, almost 500,000 people lived within a 150-mile radius of the blast site. Young girls from a nearby children's dance camp played in the radioactive warm snow falling from the sky. Cows' hides turned white in certain areas, and curious family members rode horses to Ground Zero and picnicked on the spot. In the aftermath, cancers ravaged the primarily indigenous and Hispanic communities, and all but one of the dance students died from radiation-induced illness by the age of 30. The title of this presentation is Nuclear Epidemiology: Who Can You Trust? Epidemiology is the scientific, systematic, and data-driven study of the patterns of distribution and the causes and risk factors that determine health-related states and events in specific populations. Yeah, that's pretty boring. A better definition is that epidemiology is the study of the distribution and determinants of disease prevalence in man. But as I told the Colorado House Judiciary Committee in 1990, epidemiology seems to be the Greek word that means putting people to sleep with charts and graphs. My wish is not to put you to sleep, so I am purposefully not going to use any charts or graphs. I'm not even going to use any pictures. Instead, I'm going to just tell some stories, some short stories that eventually meld into a very big story. These stories do not answer all of the questions and dilemmas surrounding nuclear epidemiology. In fact, they may raise more questions than they answer. What I have tried to do instead of giving a scientific presentation on epidemiology is to paint the picture of how we have gotten to the point in history where we are, and what, if anything, can be learned from the lessons of the past. As Bennett Cerf said, the atomic age is here to stay, but are we? I divide nuclear epidemiology into two periods: everything that happened before the Trinity blast and everything that has happened subsequently. The way radioactive materials were used and the actions and activities of individuals and governments surrounding them cannot be understood or explained without a clear knowledge and understanding of the context of those two historical periods. Although the incident in New Mexico in 1945 was the most dramatic atomic event to have taken place up to that time, and may have entered the world into the atomic age, there has always been a background of ionizing radiation in the world, and its discovery and use and experimentation had really begun more than 150 years prior to the Trinity explosion. The consequences of this experimentation also began to play out at that time. In 1789, uranium was discovered in the mineral pitchblende, now known as uraninite, by a German chemist named Martin Heinrich Klaproth. Pierre and Marie Curie later discovered the elements polonium and radium in pitchblende as well. 15 years later, Adolf Ferdinand Galen, a German chemist, noticed that when a solution of uranium chloride in ether was exposed to sunlight, it quickly changed color from bright green to yellow and precipitated. A French photographer who was trying to develop color photography in 1847 observed that light-sensitive materials, including uranium salts, could expose photographic emulsions even in complete darkness. He realized that it was the uranium salts that were responsible for this anomalous phenomenon. His discovery predated a similar discovery by Henri Becquerel by almost 40 years. On November 8, 1895, Wilhelm Röntgen discovered that the Crookes tubes he had been using to study cathode rays emitted a new kind of invisible ray that could penetrate through black paper. The electromagnetic radiation was subsequently known as X-rays or Röntgen rays. The use of X-rays proliferated quickly around the world for such things as locating gunshots, bone fractures, kidney stones, and swallowed objects. It was also used commercially to fit shoes. The indiscriminate use of the rays, however, raised some concerns in individuals such as Thomas Edison and Nikola Tesla, each of whom reported injuries they believed resulted from experiments with X-rays. Tesla also reported on the three elements of radiation protection: distance, time, and shielding. In 1901, Röntgen received the first Nobel Prize in Physics, but died in 1923 from colorectal cancer. After learning of Röntgen's discovery, Henri Becquerel looked for a connection between some phosphorescence he had been investigating and these new X-rays. He thought that sunlight might be absorbed by the phosphorescent uranium salts he had been studying and then re-emitted as X-rays. He placed uranium salts on photographic plates wrapped in black paper in the sunlight and was able to see outlines of the crystals when he developed the plates. However, during several overcast days, he placed the uranium crystals and photographic plates in a drawer and discovered that they still produced strong images on the plates. Using non-phosphorescent uranium salts, he determined that penetrating radiation came from uranium itself without any need for excitation by an external energy source. Thus, in 1896, Becquerel was officially the first person to discover uranium's radioactive properties. He died from unknown causes, but had developed serious burns on his skin, likely from his frequent handling of radioactive materials. Pierre and Marie Curie discovered the existence of radium, thorium, and polonium in pitchblende in 1898. On April 20, 1902, they successfully isolated radioactive radium salts. This led them to sharing a Nobel Prize in Physics in 1903. Marie Curie coined the term radioactivity to describe the new phenomenon she discovered in her studies of uranium in pitchblende and isolated pure radium in 1910, earning her a second Nobel Prize. Pierre was killed in a wagon accident on Paris streets in 1906. Marie died in 1934 from aplastic anemia, which was attributed to her long years of working with radioactive materials. Ernest Rutherford separated radioactive rays into beta, alpha, and gamma radiation, and in 1902, along with Frederick Soddy, explained that radioactivity was a spontaneous transmutation of elements. In the commercial world, other consequences of working with radioactive substances were also being discovered. Female factory workers in New Jersey, Illinois, and Connecticut, known as radium dial girls, painted watch dials with paint made from powdered radium to produce a self-luminous effect that could be seen in the dark. They ingested deadly amounts of radium by bringing their brushes to a point by putting them on their lips. At the time, radium was seen as a wonder drug and was being used by physicians and quacks with claims that it extended life, stimulated the sex drive, and made women more beautiful. It was used to treat everything from colds to cancer. By 1927, though, more than 50 of the radium painters had died as a direct result of radiation poisoning. The entire jaw of one woman pulled loose when she went to a dentist to have a tooth removed. Their legs spontaneously broke underneath them, and their spines collapsed. In December 1938, a world-changing event took place when uranium fission was first achieved by Otto Hahn and Fritz Strassmann, two German chemists who detected the element barium after bombarding uranium with neutrons. This discovery, along with the theoretical explanation of the event by Lise Meitner and Otto Fritsch, made the development of an atomic bomb a theoretical possibility. Scientists who were refugees from Nazi Germany and other fascist countries in Europe feared that a German atomic bomb project was already being developed. In 1939, Hungarian-born physicist Leo Szilard and Eugene Wigner drafted a letter to be sent to US President Franklin Roosevelt, warning of the development of an extremely powerful bomb of a new type, and urged the United States to acquire stockpiles of uranium ore and accelerate the research of Enrico Fermi and others into nuclear chain reactions. Albert Einstein signed the letter and delivered it to President Roosevelt. A worldwide search for uranium began in earnest. Uranium had been mined in Yakimov, Czechoslovakia for Marie Curie's experiments since the end of the 19th century. Most of the uranium used in the United States originally came from the Belgian Congo, now the Democratic Republic of the Congo. Beginning in 1921, the Shinkolobwe mine produced radium and some of the richest uranium ore in the world. Uranium ore that had been shipped to Belgium was captured by the German Wehrmacht in 1940 and was then used in the unsuccessful German nuclear program. Fortunately for the Allies, the director of the Shinkolobwe mine had also had 1,200 tons of the uranium ore stored on Staten Island in New York. And this, along with an additional 3,000 tons of ore that was subsequently purchased and shipped to the US during the war, was used by the Manhattan Project in their nuclear program. This ore was up to 65% uranium, while some of the best ore mined in the American Southwest was only 0.3% uranium. The mining operations in these three areas utilized prisoners or very poor local workers who were not told of the risks of the job, not provided with adequate protective equipment or appropriate medical care when needed. The Soviets at Yakimov used political prisoners, the Belgians used extremely poor local Africans, and the impoverished indigenous Navajo peoples provided the majority of miners in the United States. While it is not known exactly how many of these individuals suffered from medical conditions brought on by the mining, it is estimated that thousands of them died from their exposures. The American Congress eventually passed the Radiation Employee Compensation Act to provide some compensation and medical care to uranium miners in the US, but it was too late for many of them, and exclusions limited those who could receive benefits. It is scheduled to expire in July of this year, but bills have been introduced in both houses of Congress to extend it for another 19 years and to expand both the compensation and eligibility to uranium miners, uranium millers, and their surviving family members. The legislation also includes $9 million over 3 years for grants to study the epidemiologic impacts of uranium mining and uranium milling among individuals who did not have occupational exposure. Enrico Fermi and his team at Columbia University were awarded a grant by the US Navy and worked to detect the energy released in the fission of uranium, which led to the first nuclear fission experiment in the United States. A French scientist had demonstrated that uranium bombarded by neutrons emitted more neutrons than it absorbed. This meant there was a possibility of a chain reaction. Fermi and Leo Szilard designed the first nuclear reactor, a device that could achieve a self-sustaining nuclear chain reaction. By December 1941, with the US now at war, the US Office of Scientific Research and Development concluded that by using a nuclear reactor, they could mass produce plutonium. Fermi eventually built a reactor in the squash court under the stands of the University of Chicago's Stagg Field, and on December 2, 1942, the first self-sustained nuclear chain reaction, or criticality, was achieved. Fermi died in October 1954 at the age of 53 of inoperable stomach cancer. In response to the Einstein-Szilard letter, President Roosevelt eventually established what became known as the Manhattan Project for the research and development of a nuclear weapon. This project began modestly in 1939, but eventually grew to employ more than 130,000 people at more than 30 sites around the country at a cost of nearly $2 billion, equivalent to about $25 billion today. A discussion of the Manhattan Project could, in itself, take an all-day symposium. The project was coordinated between the US, the United Kingdom, and Canada, which between 1942 and 1946 was under the direction of Major General Leslie Groves of the US Army Corps of Engineers. The actual design of the atomic bombs was undertaken at the Los Alamos Laboratory in New Mexico, under the direction of Robert Oppenheimer. Pertinent to a discussion on nuclear epidemiology are the deaths of Henry Daglian and Louis Slotlin, both who died from radiation poison from critical accidents at the Los Alamos Laboratory. In 1940, Glenn Seaberg and his team at the University of California, Berkeley, synthetically produced plutonium by deuteron bombardment of uranium-238 in the 60-inch cyclotron at the University of California, Berkeley. Plutonium has the highest atomic number of any element that occurs in nature. Both plutonium-239 and plutonium-240 are fissile, meaning they can sustain a nuclear chain reaction, and producing plutonium in useful quantities was a major part of the Manhattan Project. This led to nuclear reactors being built at Oak Ridge, Tennessee, and Hanford, Washington for the production of plutonium. The Manhattan Project eventually produced two types of nuclear weapons, a gun-type fission weapon using uranium-235 and two implosion design plutonium devices. It was at this point in history when all hell literally broke loose at Trinity site. At 8:15 a.m. on August 6, 1945, the U.S. Army Air Forces dropped the enriched uranium gun-type fission atomic bomb nicknamed Little Boy over Hiroshima, Japan. By the end of the year, between 90,000 and 146,000 of its residents had died as a result of the blast and its effects. 3 days later, the plutonium implosion-type bomb, nicknamed Fat Man, was dropped over Nagasaki with between 39,000 and 80,000 deaths. Roughly half of the total deaths occurred on the days of the bombings. With the testing of one of the plutonium devices at the Trinity test site and the dropping of the uranium device on Hiroshima and the second plutonium device on Nagasaki, both fears and possibilities never before contemplated by humanity became realities. Although I am unaware of any documentation that shows there was an explicit decision made at this time that utilitarianism would guide our nation's activities, it is clear in hindsight that the underlying guiding principle was that human collateral damage was acceptable in the protection of the majority, that the ends justified almost any means needed to attain them. I cannot explain certain actions that were taken in any other way. The epidemiologic lifespan study of 120,000 survivors of these explosions and 26,000 controls has been undertaken from 1950 to today. There was initially a rapid increase in the incidence of leukemia and other hematological malignancies, which was highest in the youngest age groups. For the group as a whole, between 1950 and 1955, the excess relative risk was 15.2 or 15.2 times higher than the exposed population. This decreased over time so that for the period of 1990 to 2001, the average excess relative risk was 2.1 times greater per gray of exposure. Some years after the events, there was an incipient increase in the incidence of solid tumors, particularly cancers of the breast, lungs, and GI tract. This incidence has continued at a steady rate. The average 30-year-old exposed to the atomic bombs had a 35% increased rate of incurring a solid tumor per gray of exposure 40 years after the exposure. Almost immediately after the Trinity explosion, the US began to experiment on its own unwary soldiers, sailors, and Marines. And some of the members of the Manhattan Project began experiments on unsuspecting citizens in other ethically questionable ways. The justification for many of these experiments was the alleged need to know how exposure to radiation would affect the fighting forces during a nuclear war. How soon after exposure to an atomic explosion would soldiers be able to continue to fight? How would the effects of an explosion impact pilots and their ability to control their aircraft? What would happen to those who are on nuclear ships or submarines? Would exposure to radiation actually immunize individuals against damage from subsequent exposure? The search for a bioassay to determine exposure and the ability to use that measure to predict behavior and influence on health began in earnest, with almost no thought of informed consent or the ethical nature of the studies to be undertaken. This cavalier approach to nuclear exposure began immediately with the use of military observers and cleanup crews at the Trinity test site, and in the way downwinders, those living closest to the path of the nuclear testing fallout, were treated by the government. It continued with questionably ethical or unethical human experimentation on both servicemen and private citizens, and was a normal part of doing business with uranium miners, millers, and atomic workers at over 30 sites around the country during the ensuing Cold War period. After the Japanese surrendered, US servicemen were sent in to help with the Hiroshima and Nagasaki cleanups. Some immediately had burning, itching, and weeping sores on their skin. Subsequently, many had tumors, stomach cancer, or multiple myeloma. Between 1946 and 1962, the US conducted about 200 atmospheric nuclear tests. At least 205,000 servicemen in the US Army, Navy, and Marines were transported in to be present at varying and decreasing distances from the explosions, or flew through the mushroom clouds produced by the blasts. After leaving the services, many of these individuals developed serious health complications, including cancer. In 1988, Congress passed a compensation bill, but only for lung, bone, and skin cancer patients. Between 1946 and 1954, under Operations Crossroads, Greenhouse, Ivy, and Bravo, nuclear tests were undertaken in the Marshall Islands with mostly Navy servicemen placed on ships between 15 and 30 miles away from Ground Zero. These servicemen were given no special protective equipment, and they subsequently bathed and washed in contaminated water. Members of this cohort suffered numerous health issues, including hair loss, boils, spinal problems, benign and malignant skin tumors, prostate and lung cancers, and leukemia. Operation Ranger in 1951 was the fourth American nuclear test series and the first to be carried out at the Nevada test site. Army soldiers and Marines were exposed, but under the Nuclear Radiation and Secrecy Agreements Act, they were strictly told they could not tell anyone about their experiences, with a penalty of $10,000 fine and the fear of being shot for treason hanging over their heads. Military members were placed between 3.7 and 6.8 miles from Ground Zero detonation for Operation Buster Jangle in 1951. The Department of Defense set exposure limits of 3 to 5 RIMS per test or series for these observers, and the Defense Nuclear Agency estimated that the average exposure was only 0.6 REMS. This, however, was based on Geiger counter measurements, which do not measure internal exposure. No urinary tests or other bioassay tests were done to determine possible internal exposure. The Veterans Administration subsequently denied claims for medical expenses based on an estimate of 0.12 to 0.2% radiation exposure, which was much less than the maximum allowed. Many of those exposed were considered to be working during peacetime and were thus not eligible for disability and medical benefits. In 1979, the VA determined that 8 cancer types could be compensated for or receive benefits based on radiation exposure. The Radiation Exposure Compensation Act, originally passed in 1999, allowed a $75,000 lump sum compensation to qualifying on-site participants of nuclear tests, including atomic veterans. In 1996, Congress finally repealed the Nuclear Radiation and Secrecy Agreements Act, which now allowed atomic veterans to talk about their experiences without the fear of fine or treason. Here is a relative selection of some of the studies of the military exposures. It was determined in a 1985 study by the U.S. General Accounting Office that dose measurements during Operation Crossroads were not reliable and that there had been no decontamination procedures undertaken. They also determined that the dose reconstruction analysis had not accounted for internal contamination. The National Academy of Sciences in 1995 concluded that a study to assess any increased risk of adverse reproductive outcomes would face insurmountable difficulties, and the cost of such a study would be prohibitive. Additionally, the Medical Follow-up Agency of the National Academy of Medicine, in studying the mortality rate of Operation Crossroads observers, concluded that the findings do not support a hypothesis that exposure to ionizing radiation was the cause of the increased mortality. In 2000, the Government Accounting Office concluded that a dose reconstruction program was a valid method of estimating radiation exposure, and that there should be an independent review board to examine the program. The Board on Radiation Effects Research in 2003, under the auspices of the National Research Council, found that individual exposures during these tests was uncertain because so many of the servicemen were not wearing badges, and methods to estimate inhaled radioactive materials was subject to unacceptable error. Finally, the Journal of Radiological Protection in 2016 found a statistically significant higher rate of leukemia in atomic veterans who observed the Smoky test in Operation Plum Bob, who also had higher rates of respiratory cancers, nephritis, and nephrosis. In an ongoing search for the short and long-term effects of nuclear radiation exposure and a bioassay to help determine exposure more easily, numerous human experiments were undertaken by the medical team of the Manhattan Project and some of the most prestigious universities in the country. Just 4 months before the 2 bombs were dropped on Japan, the doctors of the Manhattan Project embarked on a human experiment so secret that it remained classified for 50 years. Beginning in April of 1945 and continuing through July of 1947, 18 men, women, and children across the country were injected with plutonium. Urine and stool samples were collected and sent to the laboratory at Los Alamos for analysis. Most of these people went to their graves without knowing what had been done to them. Between September 1945 and May of 1947, 829 women in the prenatal clinic at Vanderbilt University Hospital were given a strange tasting cocktail to drink that actually contained varying amounts of radioactive iron as part of a study focused on how a woman's diet and nutrition would affect her pregnancy and delivery and the condition of her infant. During subsequent questioning, one of the researchers admitted that we did not decide that we would inform the women. We simply felt it was unnecessary. Between 1946 and 1953, 74 boys in the Fernald State School at Waltham, Massachusetts, were fed oatmeal with radioactive isotopes in the meal or milk in a study run by the Massachusetts Institute of Technology to see if the radioactive iron or calcium would rob the children of important minerals in their diet. These boys were troubled youth and were given special privileges if they took part in the study, but they were not informed about the radioisotopes or the possible consequences. To study the effects of radiation on pilots and astronauts, 233 patients were exposed to total body radiation between 15 and 200 Röntgens, with 30 of these patients receiving an additional single dose of 20 Röntgens. 13 of the 30 died within 60 days of the treatment, and all 30 died within 20 months. The cause of death was questionable, however, because they had been chosen because of their poor prognoses. Prison convicts were used to determine the consequences of radiation on reproduction, a concern for those working with atomic workers who were involved in nuclear accidents. 67 convicts at the Oregon State Prison had their testicles bombarded with anywhere from 8 to 600 rads of radiation between 1963 and 1971. 64 men at the Washington State Penitentiary in Walla Walla were irradiated between 1963 and 1969 with anywhere from 7.5 to 400 rads. The prisoners were paid handsomely for their participation, $5 a day, and received free vasectomies. The contract for these studies had been approved by the Atomic Energy Commission headquarters, but the researchers were asked to proceed cautiously and to minimize publicity associated with the programs. On August 29, 1949, the Soviet Union conducted its first nuclear test at the Semipalatinsk test site in what is now Kazakhstan. Due to Soviet espionage and the passing of information to them by Klaus Fuchs, a British citizen of German origin who was assigned to the Manhattan Project, the device was a plutonium-based implosion bomb which bore close resemblance to the American Fat Man bomb dropped on Nagasaki. Traces of the nuclear fallout from the test were detected by the United States. The Cold War nuclear arms race had begun. In 1951, the United States exploded the first thermonuclear device, which was followed 2 years later by the Soviet Union. Until the end of the Cold War, the US would conduct 1,032 nuclear tests, and the Soviets conducted 715. The almost fanatical fear of nuclear war with the Soviet Union drove many of the perplexing and ethically challenged decisions made by the United States military and government after World War II. This fear was exponentially heightened in 1957 when the Soviets launched the Sputnik satellite into space. Sputnik shocked America in ways that even the 1949 Soviet nuclear test had not done, because for the first time, the communists were now not just catching up, but they were ahead of us in technology and science. This small satellite psychologically placed the entire country of the United States in danger. In a rush to catch up to the Russians and their apparent advantage in the nuclear arms race, the primary goal of the military and their contractors at atomic weapon production sites around the country was to build more bombs and to protect secrecy. This took precedence over all other factors, including worker safety. The pride in being part of the American Cold War effort and the good wages received at these sites, and the limited knowledge of the consequences of exposure to radioactive materials played important roles in decreasing workers' health concerns and allowing contractors to push production to levels that inevitably led to accidents. On September 11, 1957, a fire spontaneously started in room 180 of Building 771 in glove boxes of the Rocky Flats plant, where nearly 100 pounds of plutonium was stored. Officials at the Rocky Flats site claimed that nuclear exposure had been contained on site. On May 11, 1969, on Mother's Day, another major fire occurred at Rocky Flats, this time in buildings 776-777, which had 7,641 pounds of plutonium at various stages of manufacture. No criticality occurred, but 41 firefighters, guards, and other employees sustained radiation doses, with 15 receiving significant exposure. The highest exposure was experienced by a responder whose mask had accidentally been torn off. Again, the claim was made that no radioactivity escaped the building, but radioactivity was found in soil near the plant by an independent group. This turned out to be plutonium contamination from the 1957 fire. It was claimed that less than 10% of the plutonium was damaged or had burned to oxide. The fire's total of $70.7 million broke all previous records of U.S. industrial accident costs. Subsequent investigations concluded that plant contractors had totally ignored recommendations after the 1957 fire. No cause of the fire, however, was determined to keep individuals from being blamed. If the fire had breached the roof of Building 776-777, ash would have exposed hundreds of thousands living nearby to toxic radiation. In 1964, there were 400 employees contaminated at Rocky Flats, mainly by inhalation of alpha particles, and between 1966 and 1969, at least 164 fires, which necessitated calling the fire department, took place at Rocky Flats. 31 of them were plutonium fires. In addition to fires, nuclear waste storage is known to have migrated off the Rocky Flats campus. Fires and accidents in other sites operated by the Department of Energy have also contaminated large areas in the United States. With the interest and use of nuclear energy, there have also been numerous accidents and releases of contamination around the world. Some of the most notorious incidents include accidents at 3 Mile Island, Chernobyl, Toka Imura, and Fukushima. In conclusion, a study of the history of the epidemiology of nuclear exposures shows there are numerous studies that show immediate and long-term effects from acute exposure to large amounts of radiation. Such effects can be almost immediate in death to prolonged deaths from leukemia and solid tumors. The lifespan study, being sponsored by the Japanese Ministry of Health and the US Department of Energy, is the gold standard of these studies. Long-term effects from low-dose exposure are harder to quantify, but are being studied in the International Collaborative Study and its successor, the International Nuclear Workers Study. Most of these epidemiological studies focus on gamma radiation exposure. It is much harder to find articles on alpha radiation exposure, which is more pertinent to Rocky Flats. One of the best of these articles is Risk of Lung Cancer in Nuclear Workers from Internal Exposure to Alpha Particle Emitting Radionuclides in the journal Epidemiology from September of 2017. This study shows a significant relationship between alpha particle exposure and lung cancer. Further studies of Rocky Flats and the downwinders in this area will be much more difficult and perhaps financially impossible to study due to the difficulty in determining exposure. Work being done by Dr. Michael Ketterer on identifying Rocky Flats plutonium in solid tumors shows a great deal of promise in this area. I would refer you to 6 books that I have found very informational and important in my study of the epidemiology of nuclear exposure. One of those is Doom with a View, Historical and Cultural Contexts of Rocky Flats Nuclear Weapons Plant, the editor Kristen Iverson with E. Warren Perry and Shannon Perry. Second is Command and Control, Nuclear Weapons, the Damascus Accident and the Illusion of Safety by Eric Schlosser. The third is Yellow Dirt, A Poisoned Land and the Betrayal of the Navajos by Judy Pasternak. The fourth is Making a Real Killing, Rocky Flats and the Nuclear West by Lynn Ackland. The fifth is The Plutonium Files, American Secret Medical Experiments in the Cold War. And the last one is The Ambushed Grand Jury, How the Justice Department Covered Up Government Nuclear Crime and How We Caught Them Red-Handed by Wes McKinley and Karen Balcony. I would also refer you to the website cancerbenefits.com, which can then refer you to sites for uranium workers, downwinders, those who worked in nuclear weapons plants, and atomic veterans, and the benefits that are available to them currently under bills that have been passed by Congress. Thank you very much.